In this question, you just simply assign some values for the theta, and then you see which answer match your choice, then it is fine. But now I'm going to demonstrate the traditional way to solve this. The key point is to handle every ratio and then change it back in terms of theta or exact value. For cosine ratio, it starts from 1 and then form one cycle like this. Every quarter is 90 degrees. So from this graph, cosine 180, it should be the bottom. That means -1. This is -1. Sine 90 degrees plus theta. First, this is the remaining angle. And 90 degrees plus theta is somewhere here. This is the second quadrant. That's why when you change it, the sign is still positive. But however, it's related to y-axis, which swap the position of adjacent and opposite side. That's why it will become cosine ratio. After that, cosine 360 degrees. So we look here, one cycle is go back to original point. So cosine 360 degrees is exactly equal to 1. Now the final part is sine 270 degrees plus theta. So again, this is related to y-axis, and which will swap our adjacent and opposite side. That's why this will give you cosine ratio. And one thing very important is this region is cosine region, which means that it will give you a negative values of the original situation theta here. Then we just continue our calculation. The denominator are not the same, so I need to use some strategy to make the same denominator. For the first term, both sides times 1 minus cosine theta. For the second term, both sides times 1 plus cosine theta. Then they have the same denominator, which is 1 plus cosine theta times 1 minus cosine theta. We have -1 positive cosine theta, +1 positive cosine theta. Therefore, it simplified it to become 2 cosine theta above. What below, this is the form of identity. Will give you 1 square minus cosine square theta. And it's because sine square theta plus cosine square theta is always equal to 1. This is the trigonometric identity that we learned in Form 2. So 2 cosine theta divided by sine square theta is our final answer. We get C.